everybody. Sorry for the late start there. We were just having some technical difficulties that we were working on. What I will do is I will get started with the introduction, and then Cristina will go ahead with her presentation. So thank you everybody for joining us this afternoon. My name is Alicia Capello, and I'll be the moderator for this session. And before we begin, we just have a few reminders for you. The first one is that we do have a code of conduct that we will be adhering to for the conference. I'm going to post the link for the code of conduct in the chat, as well as an email address that you can send an email to if you do experience any issues that you want to report or mention. You can go ahead and send that to that email address. We also ask that you be sure your microphone is muted, and we're going to save the questions until the end of the presentation. You're welcome to ask them out loud, or during the Q&A, you can type them in the chat or in the Q&A box, either way, and I can read them out loud at the end of the session. And the session is being recorded, which has already started. And if you'd like to, you can enable captions through Zoom by clicking on the Show Captions button at the bottom of the screen. However, Cristina also has captions enabled for the PowerPoint portion of her presentation, so you can turn it on and off depending on which part of the presentation she's at. So today's presentation, as you can see from the title slide, is GraphRAG using a small language model, and it is being presented by Cristina Boggs. Cristina is a former systems librarian and consulting support analyst with over 15 years of experience. She specializes in optimizing library automation systems and integrating emerging technologies. And she is currently establishing AI services as a freelance consultant. So welcome, Cristina, and take it away.
Hi, everyone. It's nice to be here at the Gale conference this year. As she noted, this is GraphRAG using a small language model. I am going to go over some challenges that as we experience artificial intelligence and so forth, are going through right now. And GraphRAG on a small language model just happens to be sort of a bit of the solution for some of those challenges. So we're going to go through what those challenges are, what we can do, how we can do some of that stuff, and some hardware, software solutions, and some demos of GraphRAG and regular RAG and GraphRAG, as well as some settings and tools and so forth that I've gotten some experience of over the past several months as I've been doing this deep dive into artificial intelligence. So as we start here, we're going to discuss some challenges. I'm sure many of you already recognize many, if not most of these that are brought about by artificial intelligence. There's copyright issues, bias. There's actually environmental damage from the amount of energy use coming from them. It can be exceptionally challenging to library budgets based on just having unpredictable costs if you're using like a cloud-based service. The results can often be inexplicable and sadly also outright inaccurate. So part of my goal over the past several months as I've been doing this deep dive is to look at artificial intelligence and the technology under it with an eye towards librarianship and how we work and what our ethical goals, our what the world in which we live. How does artificial intelligence pose a potential benefit? How does it pose challenges? Is there a way through all of that that can be created from what we have in the situation we are in that can potentially be a benefit to all of us? So that was my goal, and the way I sort of have this sort of laid out. And GraphRAG happens to be, or the form that I'm using of GraphRAG, which is called lightrag, is basically one of the solutions that I think you guys will find very useful if you choose to go after this. So going into these issues individually, bias and copyright have similar things that you can do. One of the big ones is if you want to really control it, try and direct it towards your own trusted resources. There's a name for that. It's called Retrieval-Augmented Generation, where you provide the documents and the system sort of uses those documents for the finding of its answers. And then the AI model itself works more like it really just handles the language portion of the work, but the answers are found within the tools that you trust, that you give it. You can also advocate for resolution when you see issues with copyright and issues with bias. There will be a couple of links later on in a future slide that will show you some tools that you can use for doing that kind of reporting. But you can also advocate directly with the model producers and so forth. So, and with copyright, similar to with bias, limit the models as best you can to the licensed content that you have, and advocate with whomever you happen to be working with for the legal use of the resources when the opportunity arises. Where unexplainable results are concerned, that's an area where actually I sort of feel like we could sort of do some training for librarians in this particular area, because there are some tools out there that can sort of help some. Now you kind of have to, many of them are very highly oriented towards the statistics and so forth. There is one called SHAP that I found where you can put in some text for what you were given by the AI model, as well as what you put into the AI model. And it sort of puts the two together and highlights those fields where it sort of feels that the answers came through, which can give you a guide as to how the AI model became confused. Where environmental damage and unpredictable costs are concerned, this is very much a case of how you set up your environment for working with AI. Environmental damage, your hardware becomes very important. With unpredictable cost, it's very often on cloud-based services. You can run up a bill pretty high, pretty quickly, if you don't know exactly what you are doing. But we, trying to use these resources, need that time to sort of look around. You learn through play, right? So one of my goals here was to get you some information about an environment you can use where you can do that play. You can set something up so that you can use AI without fear of accidentally sending your library's budgets out the door. And there'll be more about that in a minute. The big one, of course, is inaccurate answers. And there are many things that you can do, and I'll be going through these in greater detail further on. And I kind of would recommend that we as a library community focus on making sure we bring these into our daily work life so that we can and use them in the way we interact with our students and with the public as well, to make sure that they have what they need to try to improve the results that they get and keep out as much inaccurate information and dangerous information as possible. So now, how can we do it? Primarily focusing on the inaccuracies and so forth. You can report anything you find that happens to be problematic. You want to do so with your vendor, whether it be OpenAI, Anthropic, Google, all of those different resources. But there are also two other resources that I think need to be brought into our library conversation and use more regularly, so that we are using the experiences where we find harm occurring, be it simple inaccurate information, to true physical harm to people, either emotionally or physically, into publicly accessible databases so that people know that these things have occurred. And those two databases that I link there cover that. They provide a database that you can search and you can go into and you can find what has happened, which models they happened on, okay? And so that you can bring that information into how you choose to work. So the rest of this is related to sort of kind of a cookbook recipe kind of thing. It's kind of an environment where if we take and look at trying to find solutions to the problems that we are experiencing with artificial intelligence, and we want to produce an environment that helps us with resolve those. That's what this kind of recipe kind of is. It's you can switch out pieces and parts and all that stuff, but that's what the goal of this happens to be. So going in, hardware, basically, it all depends upon the environment that you happen to be working in, what you do with hardware. If you're working on a cloud-based environment, then it's the business of the cloud vendor to determine what kind of chips you happen to use to provide your answers. But if you control access to if the models are being run on your local machine, then you have more control over how they're run. And one thing you can do is get what's called GPUs or graphics processing units running on your local machine to decrease the energy use because of the efficiency of those particular chips with regards to handling neural networks and that kind of algorithmic processing. If you're not sure if you have a GPU, you can right mouse click. If you've got working with Windows, you can right mouse click on your taskbar and go into what's called the task manager and check the performance tab to see whether or not you have GPUs in your system. Beyond hardware, there's also software and the AI models that you are working with within that software. With AI models, it's important to choose models that can be run on your local machine. Those are called small language models. They function very similar to a large language model. The primary difference is that actions have been taken to decrease the complexity of the algorithms within those models and the amount of memory usage that the models take. They do this by decreasing what's called the bit sizes of the neurons that are working within the neural network that produce your generative AI answer. They also do it by deleting redundant parameters that happen to be present within the model. Another kind of model that you'll need to select is called an embedding model. And that is a model that's used to take data, be it text, documents, images, sound, video, knowledge graphs themselves, and it takes those and it pulls out the entities within that data, and it gives them a numerical representation, a number. And that number is called a vector. That then is what the AI model actually uses to understand what that word means, what it is similar to, what it is not similar to, and how it can use it to respond back to you with that same word or token. So how do you find those small language models or embedding models? You find them by looking at what's called model cards. Model cards are the vendor's description of the model, and they generally include what the model was built to do, how it was trained, what it was trained on, what its final benchmark scores were, how it's licensed to be used, how you can access it, that kind of thing. Vendors include this information. There's no sort of set standard for the way in which that data has to be presented. And some models will include pieces of information that others won't. So, but you work basically from what you're sort of given from the vendor. So how do you find model cards? The links that you see here are common catalogs, online catalogs of model cards for AI models, many of which are open source or free, okay? But depending upon if you're using, for example, a cloud-based service like Azure or AWS or some of those other services, you'll also find that those companies have their own AI model catalogs that you can work to get this information from. So what in the model will tell you that you're working with a small language model? Although there's no specific rule out there that says it is or it isn't, generally speaking, a model is considered small if your 10 billion parameters or smaller. That sounds like a lot, but if you think about it, we have models out there that are hundreds of billions of parameters in them. And so giving a rough number, 10 billion or smaller generally seems kind of fair from what I've used for the number of parameters. The smaller the number of parameters, usually the smaller the physical size of the model. So it has to be a small enough model that you can download it to a local disk for use. Usually with smaller parameters, you also have a lower latency or speed for results because you don't have as many parameters to work with or go through. But you also see some language that comes up in the model card itself. One common one that is a pretty good sign that you're working with small language model meant to be locally used from your local machine is GGUF is in the name. But you might also see in the model card somewhere pruned, quantization, knowledge distillation. And a lot of these models are also built specifically for a business field. So for example, medical, math, law, that sort of thing. So if you see some reference to that, then you're probably dealing with an SLM, a small language model. Now, to be able to run it, you have to have a piece of software that's actually installed on your local machine. I've got two samples here. There is a wide variety out there on the web, though. These two are pretty easy to use. I'm actually going to show you LM Studio here in just a second. But Ollama is a non-graphical tool, whereas LM Studio is actually a graphical AI tool, okay? So let me go ahead and I am going to bring up my, my LM Studio here. Hopefully you can see this. Is that right? Can you guys see this?
Unfortunately, no, I just see a black box.
Okay, well, let me switch it here. Hold on just a second. I'm going to stop screen sharing and share again, this time pointing specifically at LM Studio. Now, can you see it?
Give it a second. Yes, I can.
Cool. All right, so let me expand this a little bit. Hopefully it'll come into your view in a more complete kind of way. So this is LM Studio. LM Studio is a tool that basically allows you to download models. It gives you a discovery service right here. You can see where you can put in a search. So if I type search for llama, it's going to go out and it's going to give me different models that it has found with that term in it. You can see at least a little bit of the model card here on the right-hand side. And then down at the bottom, you can see it gives you a download button. Now, in this case, this one's 37.14 gigabytes. That's not something I'm going to download. It does have GGUF because GGUF is also a format as a whole, but many of them are built for downloading. But you do definitely want to take into account all the different rules associated with it. You can also see it's got 70B. That means it's 70 billion parameters associated with this thing. So this is not one I would use. But that's not to say that you couldn't use Llama 3, which is 4.69 gigabytes, 8 billion parameters, and has the GGUF on it. So that could technically be considered a small language model, okay? So you can do this search, and then once you've done the search, you have access to those models that you download. You can have more than one at a time within the My Models section here. And you can see I've got both models for LLMs. The SLMs are fit inside that same window. They're all basically language models, just different sizes and so forth. And then also ones for text embedding, that translation of words into tokens and embedding vectors that the AI model can use. So, but here under LLMs, part of the reason why I wanted to show you this was because I wanted you to be able to see some of the settings. Now I'm going to jump through these pretty quickly, okay? I don't know if you guys know about these, but they can have an impact on your accuracy. So if you might want to look at your tools that you're using for AI and see if these things happen to be optimized for greatest possible use. So let me just think here. Can you still see my LLM window? LM Studio there, okay.
Yes.
All right. Okay. So the first one here is called context length, and that represents the amount of text or content that you can send the model that it can process or retain for answering questions. It's usually measured in tokens, but it's basically constitutes the memory of your model. Okay. Usually you'll want a higher number. This is controlled by the model that you choose, how much context length it can work with, okay? So if you choose a model, and you'll see this reported in the model cards, you want to make sure that you get as much context length as you can, because you want to be able to put in things, you want it to be able to remember prior conversation, you want it to be able to have a long, well-controlled prompt. You want to be able to give it additional context, for example, documents and that sort of thing that it can keep in ready memory to be able to use for answering your questions. So that's what the context length is about. I've included there in the presentation some things you can do to improve and use that context link to the best of your abilities. But I'm going to skip over those. You can look at them when the presentation PowerPoints come out. Another thing is the system prompt. The system prompt is basically what sets the guardrails or the structural rules that your AI is supposed to follow. You can tell it, for example, you can give the AI a persona. You can say, I want you to be a mean librarian or a really nice scientist, that kind of thing. You can also tell it, for example, how to handle, and I really suggest that you do this, how to handle when the model doesn't have the information it needs to give you. Because I believe they found that not having a set of steps to follow can sometimes cause an AI to just give you a big old story, which can create obviously a great deal of harm. So that's the system prompt. Some people will put into here things like full context. So they might put in, an article, the full text of an article. They might put in, I want a template, for example, for the responses to always come back in. That is what the prompt is for. The system prompt is used for. There are also here under the inference tab, two other settings that can have a huge impact on the kind of answers that you get. They both handle the randomness of the words used in the response that you get back from the AI model. The first one is this temperature, and it controls the level of predictability or the creativity of your output. Now, the challenge there, of course, is you want it to be kind of low because you want it to be very predictable. The lower the number, the more predictable your answer is going to be. But the more predictable it might be, the more you reuse the same words, that sort of thing. So it's a balancing act, not a just set it to 0 and call it done kind of thing. The same is true, or at least very similar with the top K sampling field there. The lower the number, the fewer words or choices will be given to the AI model for the next token to be selected. So you can sort of cut down the number of words that the system can use for giving you a response. It limits the next word prediction capabilities basically to that number. So those were the settings that I thought would be really helpful for you. And I'm going to jump forward here on a couple of things and get us to our next little section and reset how we're sharing. So let me bring us back here. So can you see the constrain your answer pool RAG window?
Yes, we can.
Cool. Okay, so basically putting all this stuff together. The final way in which you can sort of handle that inaccuracy is through constraining your answer pool. RAG was the first way they chose to do this. It's much older than GraphRAG, but basically the concept is you give the AI model your documents, those get pulled into the relevant parts of those documents get pulled into the context along with your prompt to provide your answer. The process of choosing for handling or getting those documents to a place where the AI can understand them is called embedding or vectorization. We've discussed those a little bit already with embedding model, but we are now going to look at the actual process. So basically you have here the text over on the far left side. It can be many different kinds of input. So text, documents, images, sound, even a knowledge graph can go into the model, the embedding model, and then it pulls out those numbers like we were talking about before, where that number represents an actual meaning for the word, okay? And then over on the far right, you can see a 3D visualization of the way the AI model sort of understands it. There are some tools for trying to get this kind of view. They can be challenging to use. You've got to have some sort of statistics sort of behind you to sort of get some of it. But you can see how conceptually the numbers represent a specific vector within this 3D visualization. And then the word associated with that, they're all positioned in such a way that the model can not only know what that word means and what it's related to, what it's similar to, what it's not similar to, how it can use that particular word. All of that is brought into the AI model and then used by the AI model to get you your answer. So once that modeling once that embedding is completed, the vectors from your prompt, because your prompt goes through vectorization as well as the documents vectors come together in the AI model and produce the response that you get through your generative AI, be it, the Chat GPT, or in this case, it's going to be the librarian tool.
Christina, I just wanted to let you know that we have about 10 minutes left. So if
Okay.
you wanted to save time for questions, just to let you know.
Okay. All right. Let me get through this real quick so that I can at least get you to the other. Hopefully we'll have 5 minutes, but I'll go real quick. GraphRAG, librarian, they're a form of the same kind of thing. You're just using a knowledge graph. Knowledge graphs, the circles are called nodes. The lines are called relationships. Nodes are entities. Relationships are how the two relate to each other. There are two different kinds of graphs. There's property graphs and RDF graphs. In our library world, we mostly are used to RDF graphs. But in the business world, they use something called property graphs. And most of the tools available for us to use in AI are actually property graphs. So I'm going to show you just a quick relationship of the two. the differences between the two. You can look at these closer later on. We're used to subject, predicate, object triples in our data, and it being really for purposes of open world linked data that everybody can use, that kind of thing. But with regular property graphs, it's key values associated with edges and nodes, and is really built for high speed and very quick processing. So that's the difference between the two. And you want to be careful which kind you're using when you choose to get into working with GraphRAG. Most of GraphRAG tools are property graph based, not resource description framework based. And the primary difference, although there are some additional ones, is that related graph nodes and relationships are brought into the AI model as well in order to get you that response, okay? So at this point, there are several different kinds of GraphRAG. LightRAG is, the reason why I chose to give you LightRAG, although it is still a graph-based form of RAG, is because with LightRAG, unlike normal GraphRAG, you can add more content to the original graph incrementally, and it will simply add the additional content. With GraphRAG, it recreates the whole graph. LightRAG is much quicker, it's less expensive, you can do more, it's more recent. It's basically an improvement on the original GraphRAG is what it is. So now I'm going to go ahead and work on getting us over to the Codemon service. So let me go over here to share. And let's see where you are. And if you want to go ahead and give me some questions, I will go ahead and try and answer them while I'm sort of balancing some of this. We might as well.
So we don't have anything currently in the chat or the Q&A window, but if anybody has a question they wanted to ask out loud, if you put up your hand, then I can unmute you so that you can ask the question.
Okay, so I've been able to find the content that I was looking for. This is a tool called Codemon that allows you to run several different variations of GraphRAG actually, but LightRAG is the better one. It runs quicker. And it has, this tool is very useful for, I've already uploaded some documents because it can take a couple minutes for individual documents to be embedded into the graph. So to save us some time, I went ahead and finished all that stuff. I also have some questions already out here that can sort of show you what it looks like. It works just like any LLM. You put in a question and then you put in a question and then it gives you the answer just like your normal LLM. And then it gives you this additional stuff, for example, the graphs that are part and parcel of GraphRAG. And then, but it also gives you the actual entities that it came into play in giving you the answer, as well as the where it found the content within the text itself from the documents that you gave it, and the relationships. So the lines and the nodes of that graph are actually listed here for you to be able to see what it pulled from where. So I can put in a question here, and it's really just going to sort of give me what is present already here in this one that came through. And in a minute or two, it will generally come back with the answer, along with the where it found that answer. You can see that stuff is highlighted from there. So that is basically the tool itself for purposes of chat. You upload the file, you get the different kinds. These are the different kinds of graphs that are available. This one is the LightRAG collection that I created that we've been running the questions through. And there's settings and other kinds of settings that you can use and change and so forth to make it very specific to what you're interested in, to what you want to sort of try and build. and optimize it for your work. So, and at that, let's go ahead and do questions as they arise.
Great, thanks, Christina. Did anybody have a question that they would like to ask? People are absorbing all the information that you gave us today. So I don't see any questions. Oh, there we go. Peter has a question. Go ahead, Peter.
Yeah, can you hear me?
Yep.
Yeah.
I've dug into this a little bit and done some workshops. And one thing I really struggle with is knowing when do I know enough to make a good decision about all of these complicated options and settings and so on. Do you have a rule of thumb for yourself on how to know when you got to that point?
So the way I sort of look at that sort of thing is, it's like the traditional river, right? You never put your thumb, your toe into the same river twice, right? And where technology is concerned, especially with artificial intelligence, it is moving so quickly, you can never be completely sure you've covered everything. I spend an hour to 2 hours every day for the past 6 to 9 months just catching up on the new stuff that comes through. That being said, there is a lot of, at some point you've got to say, you know what, I can't wait to be positive. I've got to be able to put out something and make it the best that I can make it with what I know of at this point in time. None of us know everything. I mean, this is, if there is anything all of us sort of know as librarians, it is the fact that you can't know everything. You know pathways to find information so that you can get the answer to people. The same is true here. And one of the things I did when I left working at OCLC was I wanted to make sure this is something we as a profession, we are knee deep in this before we even realized we were knee deep in it.
Yeah.
And we need to be able to not only utilize this, but help our users utilize this and make it as, and bring into it all the things that we would normally have already brought in had we sort of been in those companies at the moments in which they were making these decisions about whether or not they would put these, imperfect tools out to the world to use, right? So part of the reason why I wanted to do this, although, it is GraphRAG, it is, I think, one of the best solutions we have out there, given the circumstances of we don't have a whole lot of money to work with, like many businesses do. We don't have a lot of, hardware that we can throw at these things. We need to be able to use what we have as much as we can. And we need to be able to, teach it to people who basically didn't necessarily graduate with uh, 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 statistical degrees, to be quite honest with you. Much of the certificates and so forth that I worked on were statistics, figuring out the statistics behind some of this stuff. But at some point or another, you have to sort of say, hey, what can we do with what we have now, or at least what we know now? There's always more stuff that the vendors have it back in the back room. You know what I mean? So does that help?
I guess it reinforces what I've been doing of yeah, just plowing ahead as best I can and trying to learn.
Correct. And the
Someday
thing
though,
is, the world needs librarian voices, to be quite honest with you. They really, really need us in there. So it is something that I feel like, you know, you don't have to be the traditional library rule, right? I don't know, but I can get you that answer. You know what I mean? But you have to try. And there's always somebody who has more information, but that doesn't mean you don't have a viewpoint that might be valuable to the world. So personally, I think you're perfectly valid in putting out your views and in working with it.
Thank you.
Thanks, Christina. Well, we've come up to 3:45. We did start a little late. We apologize for that. Is there any last questions that anybody had? I don't see any. So, Christina, I guess we will wrap up by saying thank you very much for your presentation today. And this has been recorded, so the recording will be available, and I believe that the slides will also be available with all the links that I wasn't able to put into the chat. So we will get that to you probably via the main website at some point. But thank you everybody for joining us, and have a great rest of your day.